So, let us start by looking at the syntax of Python. One of the important things in Python is indentation. So, what do we mean by indentation? So, let us write a small block of code. Let us assign the value 5 to a variable a and the value 2 to a variable b. Now, I am writing an if command which is making a comparison if a is greater than b. In case this condition is true, then it is printing a is greater than b. Now, you could see that under the if command, when I have written the print statement, I have kept a small space. I have kept a small space over here. Now, this space is called indentation. Now, indentation in Python can be given by either pressing the tab key or by giving 4 spaces. Indentation is very important in Python. If you do not do the indentations properly, then during the execution of the code, it will give you an error. For example, in C, C++ or Java, people commonly use the curly braces to put a block of code together like this. So, you say if a is greater than b, then you put your block of code together in curly braces, right. In Python, these braces are not required. Rather, you put the block of code together just by giving an indentation, which is a space of 4 characters or the tab character. If at all I do not give an indentation, as in this particular case, I have said if a is greater than b, and soon after this, without an indentation, I am saying print a is greater than b. Then the Python interpreter is going to show an error. So, Python forces you to write a proper indented code. In many of the other programming languages, indentation is done for readability. However, in Python, indentation is built in the syntax of the language itself. As I already mentioned earlier, Python does not require declaration of variables. In C, C++, Java, whenever you are using a variable, you have to declare it. You have to say that I am going to use this particular variable, and you have to also say for what type you are going to use it. Are you going to store an integer value in it, or you are going to store a string value in it, or you are going to store a float or a double value in it. In Python, this is not required. You can straight away start writing your code by assigning values to variables. As in this case, I have assigned the value Anuj, which is of string type, to the variable name, and I have assigned a value 36 to the variable age, and therefore age is of int type. In order to print these variables, I can use the print statement print name comma age. So, as I just mentioned, Python automatically recognizes the data type based on the value that is assigned to the variable. Now, in this example that I have in front of you, what you observe is, first of all, I am storing a value 5 in x. So, as soon as the Python interpreter interprets it, it says that okay, x is of int type. However, as soon as it goes to the next statement, then I am reassigning a value hello, which is of string type, to the variable x. So, in the first statement, x is of int type. However, in the second statement, x becomes of integer type. So, 5 is replaced and hello is rewritten, and the type of x is now string str. And therefore, in line number 3, when I print x, this will print hello, as the variable is storing the value hello and 5 has been overwritten. There are three numeric types in Python: integer, float, and complex. Now, variables of numeric types are created automatically as soon as you assign a value to them, just as we discussed earlier. So, when I say x is equal to 23, it is of integer type. When I say y is equal to 5.6, now since it has a fraction value or decimal value, this variable y is of float type. If at all you are working with complex numbers, then in that case you need to use the symbol j. So, if I say z is equal to 1 plus 2j, then in that case 1 is the real part and 2 is the imaginary part, and therefore 1 plus 2j is a complex number. At any stage of your program, if at all you want to identify what is the type of a particular variable, then all you need to do is use the type function. Just write type and the name of the variable within the braces, and Python will let you know what is the type of the variable. There are a variety of operators in Python. Now, following is the list of operators. There are arithmetic operators: plus, minus, star, divide, double slash, percentage, and double star. We will see in a while as to what these operators do. So, let us go to the Jupyter Notebook, open Anaconda and launch the Jupyter Notebook from here. Let me go to the desktop and create a new folder. Let me rename it to data science. Let me go inside this folder and create a Python 3 notebook. Let me call this notebook as tutorial, and let us get started with testing the arithmetic operators. So, some of the arithmetic operators that we looked at were plus, minus, star, and slash. So, these are the operators that all of us are aware of. Let us try these operators first by saying that let us say there is a variable which is storing a value 12, there is another variable b which is storing a value 23, and I want to do some mathematical operation and store it in a variable c. So, c is equal to a plus b, and then I say print c. After doing this, I can either press shift enter or I can go over here and run this piece of the code, and as you could see that the mathematical operator plus is at work over here, and it is assigning the addition of the two variables a and b in C and printing it for us. Let us change it to minus. Let me press shift enter. This is the result. Let us use star. This is the multiplication, and let me use slash and press shift enter. So, this is the division. But as you could see, there are a few more operators over here. For example, the percentage sign, the double star sign, and the double slash sign. Let us see what do these three operators do. So, let us say a is equal to 8, b is equal to 3, and c is equal to a double star b, and then I say print c. So, the double star operator is the exponent operator. It is a to the power b. So, if at all you print the result, you see that 8 to the power 3 has been printed in front of you, which is 512. So, let me write it down for you. Now, this is how you write comments in Python. So, if at all you want to embed comments in the code cells, use the hash symbol to start your comments. So, this piece of code uses exponent. Let us write another piece of code that uses the remainder operator. So, A is equal to 8, B is equal to 3, C is equal to A plus B. So, let me change this plus sign with percentage sign, and then it becomes the remainder operator. As soon as you do this, what you find is that when you divide 8 by 3, then it gives you the remainder, which is 2. If at all I change the value of B to 2, then the remainder should turn out to be 0, and that is what we get. The third operator is the double slash operator. Let us look at the double slash operator. Let's see what it does. Let me copy this piece of code. And let me say double slash over here. Let me change the value of B to 3. Now, as soon as you do this, you get the answer 2. So, now what this double slash operator is doing is, it is also dividing A by B, but then it is ignoring the remainder part, right? For example, if at all I make it 20, then the answer, if at all I am using it as the divide operator, will be fractional, which is 6.666. However, if I use the double slash operator, then the answer will turn out to be 6. The remainder part will be ignored. So, these are the various mathematical operators that are available in Python. The next thing that we are going to look at are the assignment operators. So, there are quite a few assignment operators. Some of them bear quite a bit of similarity as you use these in other programming languages as well. So, for example, equal to sign is used for assignment. So, as soon as I say A is equal to 5, then in that case 5 is assigned to the variable A. Let us use it. So, the value 5 has been assigned to A, and therefore, the equal sign is the assignment operator. Let us look at a few other assignment operators. A plus equal to 2. Let me print A again and see what this operator does. It prints 7, right? So, when the value of A is equal to 5 and I say A plus is equal to 2, then it prints 7. So, what it basically does is that to an earlier value of A, it adds 2. So, A plus equal to 2 is equivalent to A is equal to A plus 2. So, A plus equal to 2, this is equivalent to A is equal to A plus 2. Similarly, if I have the minus sign, A minus equal to 2, this is equivalent to A is equal to A minus 2, and you can do similar sort of assignments using star equal to, divide equal to, and so on. Let us try A minus equal to over here. Let us change this. a minus equal to 2. Now, let us run the first piece of code. The value of a is 5. Let us run the second piece of code. Now, what you see is a minus equal to 2 is equal to a minus 2, which is 5 minus 2, and the output is turning out to be 3. Let us go to the comparison operators. There are quite a few comparison operators as well in Python, and these are the few that I have listed in front of you: the double equal to, not equal to, greater than, less than, greater than equal to, and less than equal to. Let us see what do these operators do. They always compare two variables. So, one variable or one value has to be there on the left hand side, and the other variable or other value has to be on the right hand side of these operators, and it makes some sort of a comparison that are these two quantities the same, are these quantities not the same, is one quantity greater than the other, less than the other, and so on, and they always return the answer as true or false. So, let us create two variables again. This time let me create two strings. Hello, b is equal to. Now, if at all we want to check that whether these two strings store the same value, the operator that we can use is the comparison operator. So, let me just make a comparison. Print a equal to b. Now, a double equal to b is going to print either a true value or a false value, because these are the only two values that these operators, the comparison operators, will return. Now, if at all I print it, what it says is that a double equal to b is false. The two are not equal. Let me create a new variable c, which also stores the same value world, and let me compare c with b. Now, this time the answer is true. Let us try using the not equal to operator. A is not equal to b. Now, if at all I print this, the answer will be true because a is not equal to b. However, if I do c is not equal to b and print the answer, then it will turn out to be false. Let us use the greater than, less than, greater than equal to, or less than equal to operators as well. Now, let us apply these operators to integers. A is 12, b is equal to 13, and then we say print a is less than b, and this should give the answer as true, that yes, this is true. If I say a is greater than b, then it should give the answer as false. And similarly, you can use greater than equal to, or you can use the less than equal to operators as well. The next few operators are logical operators, membership operators, identity operators, and bitwise operators. Let us look at a few of these. You have two conditions to check, and these two conditions need to be put together using logical operators like and, or not. Then the logical operators are useful. For example, let us say I have three variables: a is equal to 15, b is equal to 12, and c is equal to 15. Now, I want to check whether a is greater than b as well as a is greater than c. So, in this case, what I want to do is print a greater than b and a greater than C. Now, if you do this, what you observe is that the first check that you are doing, A is greater than B, is satisfied. However, the second check that you are doing, A is greater than C, is not satisfied, and therefore, when you do this print, then it will give you false. If I replace AND with OR, then basically what we are saying is either of the two conditions can be true, then it is acceptable to me. And then if I click Shift Enter, I get the result as true. The NOT logical operator simply reverses true to false and false to true. Now, what are membership operators? Membership operators are used to check that whether a particular element is a member of a particular data type. For instance, we will be talking about lists in a while, but let me create a list which contains some string objects. A list is defined using the square braces, and the items in the list are separated by commas. So, list is equal to, let us say we have the name of some fruits, bananas, grapes, and oranges, right. Now, what I want to do is, I want to check that whether another fruit, which is kiwi, is it a member of this list, right. So, what I will do is, let me print kiwi in, let me call the name of the list as L, print kiwi in L, and the answer is false. So, in is the membership operator. However, if I change kiwi to bananas and I print, then it says that yes, bananas is a member of the list L. Therefore, the membership operators can be quite useful in checking that whether something is a member of a particular variable instance or it is not. At this point in time, let us do one thing, let us make a calculator. So, let us create a calculator using some of the things that we have just learnt. So, let me create my notebook where I am going to write few comments in this particular cell. The calculator will do the following tasks, right. Now, this is the heading. Now, what I can also do is, I can put some rich text in this. For example, if I put a star, this will become a bullet. So, let me say the code will do addition, it will do subtraction, it will do division, and it will do multiplication. Now, after writing this, if you press Shift Enter, this is how the markdown cell is going to look like. So, as I said earlier that you can combine your notes along with the code that you are writing. So, this is exactly what I meant. So, let us create two variables, A is equal to 100 and B is equal to 200. The operation that I want to do is, let us say, addition. So, we have created two variables A, B, and the operation that I want to do is addition. So, if operation is equal to addition, then in this case I want to print A plus B. Now, if you look at the if statement has the comparison operator in it, where it is checking that whether operation is equal to addition or not. Now, this operator will return a value either true or false, and based on that the block of code under if will either be executed or not executed. Just notice that after the comparison there is a colon sign which denotes that we are going to write a block of code under if. As soon as you press enter after the colon sign, the Jupyter notebook will automatically put an indentation. So, let me write it for subtraction, division and multiplication as well. Now, for subtraction we do not have to write the code inside it, rather now we need to move outside the earlier block of code. So, if operation is equal to subtraction, in that case print A minus B. Again move back and say if operation is equal to division, then print A divided by B. If operation is equal to multiplication with a colon sign, then print A star B. Now, if at all I execute this piece of code, the answer is 300 and addition is being done. Now, let me change addition to subtraction. Now, as soon as you make this change, you have to execute this piece of code once again, because the value of the variable operation is still stored as addition in the memory, and therefore, it is very important that whenever the earlier piece of code is changed, you should re-execute it. So, let me execute this and let me execute this. Now, we see that the answer is minus 100 and subtraction has been done. What you can also do is you can use the input statement to take inputs from the user. For example, you can use the input statement and ask the user, what do you want to do? Now, as soon as you ask this question and execute this piece of code, it will prompt you, and here I will say division, and when I press enter, the first piece of code is executed and the value of division is stored in the variable operation, and when you divide 100 by 200, the answer is 0.5. Similarly, you can take inputs for A as well as B. So, we are done with making our calculator with whatever we have.